So thank you all for coming. Like he said, my name is Brian Knoll. I work with Webb Associates here in Riverside. I've been there for about 16 years now. When I come and do these things, my wife, she always tells me, she says, okay, don't nerd it up, right? Not everybody cares as much as you about wastewater treatment. And I say, okay, all right, I'll try. I'll do my best not to totally nerd it up, okay? But there are some important things that hopefully you take away from this as you guys are studying public policy and how your work interacts with things that I do, or as the engineering community does, and why those things are important to work together and understand each other. Just by a raise of hands, we can kind of see who we have here today. If you're a student, an undergraduate student, will you raise your hand? Okay, how about a graduate student? Okay, a couple. Thank you for coming. All right, you knew there was cookies, huh? There you go, okay. How about faculty in the public policy group?
Necessarily public.
Okay, and faculty. Okay, good. So like I said, hopefully what's one of the things that you gain out of this is a better understanding of why the technical aspects of engineering, of infrastructure are important to you. I go to a lot of city council meetings, public municipality workshops, board meetings, and I get the opportunity to listen to public policymakers try to explain to the public why they should implement the solutions that we recommend without having any idea what they're talking about. And it can be incredibly frustrating for the policy maker, for the community, and for the engineering group, because I sit and listen and go, oh, did you really just say that? Right? And they listen to me and go, why are you nerding it up? Like, come on, nobody understands that stuff, right? And the public sits there and goes, why am I going to give you more of my hard-earned money when you have no idea what you're talking about, right? So hopefully at the end of this, you'll have just a little better insight about one aspect of these public policies, which is what I do, wastewater treatment and recycled water implementation. So that's kind of the goal of what we have here. Some of it may be a little technical, some of the jargon. I tried to simplify it and make sure everybody understands some of the jargon that we use. If you don't understand something, there'll be time for questions and answers at the end, and we can go through that. But that's really the goal, and my hope is that we'll be able to come to a better understanding of each other as we go through this. So a little background on the project. The Western Riverside Regional Water Reclamation Facility, we call it WRCRWA for short. It's a 5-member JPA. The facility is located in Eastvale, right in the southern tip of the city of Eastvale, right about where Prado Basin and the Santa Ana River are located. It's a 5-member joint powers authority made up of the city of Norco, Home Garden Sanitary District, Western Municipal Water District, Harupa Community Services District, and the city of Corona. So they jointly own that facility. Western Municipal is the administrator, so they operate the facility, and they also administer all the finances and cover engineering and things like that for the facility. But they all work together and jointly own it. They all have different capacities, ownership there. The plant was originally built as a design-build project. This is a delivery method for the construction of the design and construction of the facility. One of the challenges that it faces is that very limited redundancy in the plant itself, and we'll talk a little bit more about that as we go on. It has 8 million gallons a day capacity at the facility, and then the drivers for the additional capacity was really growth in the service area, the build out of Eastvale, some additional areas in western service area, and then the city of Corona decided they wanted to buy in to that facility so that they could increase their capacity for their future growth and switch around some things on their side of at their treatment plants. So they wanted to join in. So then also with that is the need for recycled water and kind of why do we need recycled water? So all of the owners they're all looking at serving water to their customers, And the ability to implement recycled water directly translates into a reduction if somebody's using regular potable water to water a park, a landscape median, anything like that. They can take that off of the potable water system, then they can use that water somewhere else, use recycled water for that. So at 6 million gallons a day, which is kind of the average what they're treating now, that's roughly equivalent to about 24,000 houses that you could, if you can substitute that water, right, parks, medians, landscape, those kind of things, you can substitute, and then you can all of a sudden start serving on the potable system somewhere in the neighborhood of 24,000 residential homes. At full build out, about 13 million gallons a day, you're talking about over 50,000 houses. So that's the trade-off when you're talking about implementing recycled water into, for irrigation, for groundwater recharge, aquifer storage, right? That's the trade-off. That's what we're talking about. So service area-wise, most of you are probably kind of familiar, but the plant sits here at the south end of Eastvale, serves all of Eastvale, all of Norco. A portion it will serve a part of the city of Corona, and then a Home Garden Sanitary District, a little small district there, and then a portion of Western's western part of their service area. So UCR 91, right? 215, we're like right here, right? We're like right up here at the northeastern portion of Western Municipal Service Area, okay? So as far as recycled water goes, where do they have facilities? Who has recycled water? The city of Corona has a very robust and advanced recycled water system from treatment and distribution. They also do groundwater recharge. They have recharge basins where they take excess water that's not being used for irrigation and they put it in the ground to do groundwater recharge. It's not direct to their potable water system, because it's downstream of their wells, but they do support the groundwater there. The city of Eastvale has huge needs for recycled water, but they don't currently have any recycled water infrastructure. But any of you who have been to Eastvale, there's parks, there's open space, there's lots of areas with need for recycled water, but they don't currently have recycled water infrastructure in the ground. Their parks are, a lot of them are either on the potable system or on non-potable wells that are drilled with high nitrate wells. So they have a big need there. The city of Norco has needs for recycled water throughout their service area. And then Western and Home Gardens really don't have any need in their kind of adjacent service area for recycled water, not a lot of demand. So those are the players who really want the water and need the water and can use it to offset potable water demands. So some of the regulatory framework, you may be familiar with Title 22. California regulations, Title 22, govern the use, production and use of recycled water. So it contains the treatment requirements for producing recycled water. In there it also contains the redundancy requirements for recycled water, what you have to have in order to be able to produce that water, and then also monitoring. The monitoring and redundancy are really important. As you're producing recycled water, you have to continuously monitor it, make sure it's meeting the water quality standards. If it's not, you have to be able to shut it off right away so that water that's not meeting the requirements and standards isn't going out into the system and then potentially subjecting residents, citizens to contact with water that's not meeting the standards. One of the other issues that we faced at this facility was this change of use petition. So historically, the water is treated and then it's discharged into the Prado Basin and into the Santa Ana River, downstream, down into Orange County. In order to pull that water out, the owners had to go through this change of use petition with the state board in order to be able to utilize that water that's historically been going down the river and be able to pull that out for their own beneficial use. They've just recently, within the last week or so, gotten approvals to be able to do that. They have a pretty arduous monitoring requirements that they have to go through to make sure they're not hindering environmental impacts on the river in the basin because the water's been going there for so many years. They can't just pull it out and then negatively impact habitat that's been sustained by that water. So they've just recently gotten approval to be able to pull that water out. But that was a 3-year process in itself, just to get that change of use done. So one of the issues that I wanted to touch on, because this directly impacts public policy makers, and I want to show you kind of what has evolved, and I'm not here to take sides on whether it's good or bad. It just is, okay? But it's important for you as public policy makers, future decision makers, land planners, and all those things to understand the impacts of the decisions that are made. So this is an aerial photo from 2003, not long after the facility, which is here, was originally constructed. To the west was an active dairy, okay? They had at one point, I don't know how many, it was like thousands of cows there, right? Side story, right? This dairy, when I used to drive up to the plant, you would drive up, it smelled like a dairy, okay, first of all. You would drive up and you would make sure you had all of your stuff in your hands, right? I got all my stuff I need. Open the door, jump out, close the door as fast as you could. When you come back, you do the same thing in reverse. I got all my stuff, open the door, jump in, close the door as fast as you could. And no matter how fast you could do that, there would still be at least 5 flies in your car. And then, right, we've all driven down the road trying to get the flies out of the car, right? As you roll down the window and you're trying to shoo them out, right? Okay, so this was an active dairy to the west, the facility, and then there was a compost facility, other dairies all around, okay? Great neighbors for a wastewater treatment plant. 2011, when we started this project in 2011, this is what the landscape looked like. Our plant, the dairy, now there's houses here. Pretty good buffer, right? This is still open space, right? These people, not sure if they knew that the treatment plant was here or not. There's still a dairy. There's other dairies around. It didn't really bother anybody, okay? So that was when we started the planning and design for this project back in 2011. 2017, now, as we are finished, dairy's gone. Cows are gone. No more flies. No more smell from the dairy either. And we got new neighbors. Okay? So this tract of houses that land was zoned commercial. Okay? County of Riverside zoned that commercial. Somewhere along the way, somebody convinced the County Board of Supervisors to change the zoning of that to residential. This is county, and nobody bothered to tell the wastewater authority or the city of Eastvale, apparently, though this is before Eastvale was incorporated, the wastewater authority that they were going to build houses like literally from me to the back of this room, away from some of the stinkiest parts of the treatment plant. Okay? Like I said, I'm not here to say whether that's good or bad or indifferent. It just is. But it's a problem when you let people move in to this house right here and this house right here, and you don't tell them that that's a wastewater treatment plant that smells. And their disclosure statements say, you're living next to a water purification facility. It's true, right? To some degree. Right? But really not totally honest. Okay? So in the middle of our project, we have neighbors moving in and go, oh my gosh, it smells terrible. Like, well, yeah, you know what that is, right? Well, I don't care, right? And public doesn't care that they just bought a house next door, and someone might say that that's a bad decision. But California law doesn't allow you to negatively impact your neighbor like that. So the ratepayers who built this facility and are paying for the new upgrades to it got about a $6 million extra bill in order to try to build odor control facilities into this treatment plant, okay, that nobody was really planning on because nobody knew that they were going to build these houses right here. Okay? So land use decisions have impacts that go far beyond what sometimes is considered in a council chambers. Okay? And these are important things that happen that you then have to deal with. And they've been dealing with this problem ever since they moved in. They got sued, right? They're going through the process, trying to figure it out. We're trying to implement solutions. They say, well, we don't care. That's not good enough. And it's in this continuous, maybe forever problem because the decision was made to allow these two uses too close together. So the existing plant, this is it. I want to just show you some kind of a preview of what we did to improve it. And this is where it gets maybe a little bit more technical. But I think as you understand what it takes to design, construct, to implement a project like this, it'll give you a better understanding and a better appreciation maybe for the things that you end up approving or the things that you end up pushing forward and saying this is a good idea and this is how we're going to do it. And the more you understand about it, the better you can explain to your public about why we need to do these things and why maybe it's difficult, okay? Instead of the policymakers saying, we're going to do this improvements and we're going to fix the smell, not really understanding what that statement means, right? That maybe you'll just have a little better. So I want to show you what we ended up doing, so as we talk about it, it'll make a little bit more sense from a visual standpoint. So we added primary treatment. Improve the headworks. Okay, this is where you take out the large stuff that people send down their sewer, right? And it comes in. It may be biological. It may be trash. It may be debris. I mean, you'd be amazed at what ends up coming. And so this is where that happens. And then primary clarifiers and treatment equalization. Then from there, we're adding secondary treatment, aeration basin, secondary clarifiers. This is where the biological activity happens. Funny, I was just giving a talk to my, yes?
Can you just explain what aeration means?
Oh, yes. Okay. So I was just giving, last week I went to my son's 8th grade class, and they asked me to come give a talk about wastewater treatment. And so 8th graders, you can imagine, if you guys remember back when you were an 8th grader, they love talking about bathroom talk. Like, they love it. Right? I find a lot of people do, right? Even my older friends, right? They fall in one category. They're either completely, like, just infatuated with the whole concept and idea of what we do, or they're completely grossed out, and some of them are both at the same time, right? And these 8th graders were like, wait, what? Like, you know, I asked them, where does it go when you flush the toilet? And they're like, in the ocean. I was like, what? Right? And so, anyways, so this aeration basin, this is where like the real heavy lifting of the treatment process happens. And there's microorganisms and bugs and bacteria that just love your feces. They love it, right? And the only thing they ask for is more of it and oxygen. That's all they want, right? And they just go all the time. And they consume it, and they eat it, and they help us clean up the water. And that's what happens here in this process, right? And you can be infatuated or you can be sicked out. It's all the same, right? It all happens. Then from there, there's tertiary treatment, and this is where you get into Title 22. You have to go to tertiary treatment. So we filter the water, and then we disinfect it to a level that the state of California is determined to be safe to killing viruses, microorganisms, the things that will make us sick. Those were recycled water facilities. We're implementing a pump station and a tank to be able to distribute the recycled water. And then we did several changes to their solids treatment and disposal systems, and that's what all this is. So one of the things that's important to understand is how do you execute a project like this? It's not simple. It's, like I said, I started working on this project in 2011, and we're just finishing it now. Okay, so this is 6 years, 6 solid years of planning, design, funding, construction, and then getting the whole facility started up. Okay, so just to make it sort of simple, looking at what are the steps that we go through in order to do this. One is determine the existing capacity. What's there now, right? What do we have? And then what do we need to do? We need to understand the owner's needs. Each one of those 5 owners has different needs. They're not all the same. We need to understand what those are so we can develop a solution that satisfies each one of them, okay? Then with an existing plant like this, you have to integrate it into the existing operations, okay? Sort of like, and then review of constructability. Sort of like if you're driving down the street and you decide that you want to take apart your seatbelt and put it back together while you're driving, right? You don't get to stop, pull over, do all that stuff, and then restart again. Because every day, people are flushing their toilets. Every hour, every minute. You don't get to tell everybody, hey, stop for 2 years while we're doing this, and then come back. You have to do it on the fly, live, with people still living in their houses, and they don't want to hear about a disruption in their service, okay? So integrating with operations and being able to build it. And then evaluating life cycle costs. One of the issues and one of the drivers for this project was to try to reduce the operating costs, try to reduce what everybody pays every month in their user fees, okay? And try to reduce that. And you kind of go around and around and around this circle until you come up with an answer that satisfies all of these things to the best of your ability. Some of them are really good ideas. We came up with great ideas, but we couldn't build them without stopping operations at the plant. So that's off the table. We can't do it, right? We came up with ideas that were really good, but they cost too much, okay? So you just got to go round and around and around this circle until you get to a place where you've satisfied at least enough of the concerns, enough of the demands that you're ready to move forward, okay? So I'm going to talk a little bit about each one of these things, and I've got some examples of things that we did and looked at as we went. So this one's existing capacity. Each component, what's its capacity, right? So then we know, okay, if we're going to go from on the headwork screens, they can do 8 million gallons a day. Well, that means we need more screens in order to get to 14 million gallons a day, and so on. So we have to come to a basic understanding of what do we have, and what do we need. So then understanding the owner's needs. As I said, each one of them had a different driver for what they needed, okay? So home gardens, they needed just a little bit more capacity. They're kind of built out. They need just a little bit more capacity to serve all their future needs. City of Corona had no capacity, but they wanted 2.5 million gallons a day so they could offload some of the flows at their facilities. Norco needed a little bit. JCSD needed to plan for the entire build out of Eastvale, okay? So they needed more. And then Western said, we're good, we don't need anything. So then satisfying all of their demands and all of their needs with then how do you pay for it? How do you structure a deal so that they're all happy with what they're paying? Just another complication of having 5 owners. So I said the project objectives were to go from 8 million gallons a day to 14 million gallons a day, reduce the cost, everybody's user cost, and then produce recycled water for the north service area up into Eastvale, the south service area, Corona, Norco, being able to get water down into both of those. And then we're given a budget, $72.5 million to accomplish all of that. That's what you've got. That's what you've got to spend, okay? So with a given budget like that, that's given to us based on policymakers, decision makers. This is what we can do. So then every decision you make has to fit into that framework. We say, well, we'd really like to do this, but that gives us a project cost of $80 million. It's out. We can't do it. So you've got to do the best you can with the budget that you're given and maximize all of those different constraints. So as I said, integration with operations. This one's crucial in an existing facility. And as I said, as a policymaker, understanding the complexity of a facility like this will really help you sell or explain to your constituents, to your public, why it's important, okay? If you've never been to a wastewater treatment plant, if you've never had your customers go to your facilities, it's hard for them to grasp why this is complicated and why it's hard to do and why it's expensive. They say, $72 million? That's crazy, right? But that's what it takes to do something like this. So this facility, as I said, had limited redundancy. This is the oxidation ditch. Basically, this is like a slurry mixture of what looks sort of like frothy chocolate milk, but it's not. Okay? And it goes in a serpentine fashion, aeration, right? The bugs are in there. They're consuming the everything that's in there, right? Doing their thing. This is the only one of these that they have at the plant. It can't go offline. It has to run 24/7, no questions asked. So we needed to do upgrades to this. We needed to fix this and improve the aeration system. We started figuring out, how are we going to do that? So we came up and we designed a new aeration system. And we did it in a way that we designed these aeration grids. These are normally, you would drain the tank all the way down, and you would put these in, you'd install these in the bottom, and you'd bolt them down to the floor. But we can't do that. So how are we going to do it? So we came up with a design, and we put these on concrete ballasts so that we could take them, set them in while the water's still running, and that they would sink to the bottom, and they would hold themselves down there. So we had to get everything all prepped and ready, blowers in, piping in, these all built. And then we came up with a problem. We thought to ourselves, how are we going to test this to make sure it works before we put it into the dirty water? Because once it goes in the dirty water, it's dirty, right? And you take it out, and then you got to clean it off if there's a problem with it, and nobody wants to go touch it, and all the problems, right? So how are we going to do it? We got to test it outside. So, you put your head together, and you start thinking, and you say, we built a little pool, right? And so very simply, we put them in the pool, we hooked them up to the air, we could check every one of them, see, right, if it was working, if there was a problem. If there wasn't, we could tighten it up. It's clean water. Nobody's upset about that, okay? Then we had to put them in. This was the day that they went and did their installation. Every one of these is one of these diffuser grids that they're installing into the oxidation ditch. Okay? And then they would hold this hose, and they would come and they would plug it in to the air header, connect it. We were able to do this live in one day. They were able to set all 19 of the diffuser grids, turn them on, and get it all set up in one day without taking the ditch offline. Okay? Which was a major task and a potential problem for the project. Oh, come on. This is what it looks like now. It's all done. Okay? So the same is in reverse. When they need to fix one of these, they can't take this whole thing offline and drain it. So we made it so that they could go and they could set a crane, and they've got a bar that they hook this up to, and they can pull those out and be able to fix them when they need to without taking the whole thing down and out of service. Okay? So there was other areas where we had to integrate with the operations. We had digesters. So you have biosolids that get taken out of the water, right? As we're cleaning it, we're taking the dirty stuff out of the water. As we clean the water, we got to do something with that. So we have digesters that we have more bugs and more biology that consume these. They turn some of it into methane gas in these digesters. Well, we had to convert these, cover them, do all the improvements, again, live. So we took one off, we fixed it all up while the other one was running. We put the new one online, we took the second one offline, fixed it all up, and then put it online and sequenced it that way, and had to work with the operations group to be able to do that. There's just a few more places where we had to do that. Okay, so this is one that you start to ask questions. Me as a supervising engineer, I ask our team, and you as a public policy maker, as a decision maker, should ask this question. Have you thought about all the places where you are connecting to something else? Okay? In my experience, this is where the problems, not all the time, but most of the time, where they come. When you're connecting to something else that's already there. okay? And so I tell my team, said, at each one of those points, you have to have a good solution for how we're going to do that, okay? You don't have to have 100 good solutions. You just have to have one, at least one. If you don't have at least one, then what happens is when the Mr. Contractor comes to build this, he says, I can't do it. And you go, well, yeah, you can. And he says, well, how would you do it? And if you don't have one good answer, one plausible way to do it that's realistic and doable, then you just basically took the owner's wallet and laid it on the table and said, okay, Mr. Contractor, how much is it going to cost? Okay? So I tell my team, you have to have one good way, at least. Hopefully you have maybe more than one, but you only have to have for sure one in order for us to be able to get through this. So we had 4 of these spots at the treatment plant that were really critical, where we had to connect to something that was already there and already in operation. And how are we going to do it? Okay? And so one day I'm sitting in my office, and we had a way for each one of these things. I'm sitting in my office, I'm kind of minding my own business, just doing whatever I was doing that day, right? And I get an email from the construction manager out at the plant, and he says, hey, check out this picture. What do you want us to do? I'm thinking, that seems kind of simple. Like, you know, I get stuff like that all the time, right? So I click on the attachment, I open it up, and this picture comes up. And it's probably not scary to you, just looking at it, but very scary to me, okay? So this pipe, this one's 42 inches. This one is 20 inches in diameter, right? So this is a big pipe. Inside of this tank is 6 million gallons of untreated wastewater, okay? This pipe was hanging here. This picture, actually, this is a picture a little bit later. They had put the straps on. This pipe was actually hanging in the air, totally unsupported and not restrained. Which means at any second, it could have come apart and it would have drained essentially the entire contents of that tank out. 6 million gallons of raw sewage spilled out to wherever gravity wanted it to go, okay? And I, like, pick up the phone immediately, right? Like, what in the world are you guys doing, right? You've got to restrain that pipe. You're like, that is unacceptable. So they went and they quickly did this, okay? The problem, we thought, is that the old plans, this was all underground. The old plan said that that was a steel pipe and it was fully welded and connected, right? Which is very stable, very safe, okay. It turns out it's a ductile iron pipe with push-on fittings that are not restrained and can pull apart if there's enough pressure on them. And if that pulls apart, you're not stopping it until it's done. There's no like, oh, we'll just go in and we'll like fix that up. No, you get to stand back and watch it go until it's done. Okay? Scary. Like, these are just things that happen, and you thought you did a good job, you thought you knew the problems, you thought you knew the risks, and then you find out that you really didn't know. Okay? So, we had to get in, and we had to plug this line so we could disconnect this line. Okay? So, how are you going to do that? Well, you go in at night, and you get a crew together, and you got to get this big 42-inch diameter plug down into the hole that's 16 feet below the water surface down in there and plug that line. So how do you do that? You get this guy to come and take a swim. Right? So this guy shows up, and we tell him what we need him to do, and he's like, okay, no problem. Okay? And he takes a swim and goes over. You'll see him, he kind of bobs and makes his way over in his scuba suit, and he drops down to the bottom and pushes that plug in so they can inflate it and stop the line. Okay? Funny, I talked to that guy after, and I was like, that's disgusting. And he says, oh, that's not even close to the worst of these that I've done. Okay? So he goes all around the world and does ridiculous things like this that nobody else probably wants to do, right? But I'm super grateful that there's somebody that is willing to do that, right? Because we needed him, right? But he told me about that he went and he was deep diving on oil rigs, okay? And he would have to go down in this pod and go down, and if you're familiar with how this works, the diving, right? You go down, you have to get acclimated and everything. You can't just come back up. They put him in a pod, and he lived in this pod hundreds of feet below the surface of the ocean for 30 days at a time. Right? That sounds awesome, right? It's like a little pod. Right? I said, well, what would you do? He said, I would work for 12 hours straight, and then I would come back to my pod, and I would sleep, and then I would go back out. And he had a partner, and they would cross paths every 12 hours or so, right? And go back and forth for 30 days. He's like, this, no problem, right? It's just a little sewage. It's fine. It's okay, right? I'm not stuck in a bubble for 30 days, hundreds of feet below the ocean. Right? So what do you deserve after you go diving in sewage, right? This is a highly high-level chlorine bath that he got to disinfect him when he came out, right? But I am personally grateful for people like that diver who are willing to go in and do that. This is what it looks like when it's done. It all came through okay, no spills, no problems, and then I got to get regular sleep after that, not having to worry about it. There's just a couple other things. You know, we had to implement new screen while these ones were being replaced and running, and they're still scooping all the stuff that everybody flushes down their toilet, right? Every day, it's coming through, right? So how do you deal with that while you're taking out existing pieces of equipment? Okay? It's just something you got to think about because it doesn't stop. It just keeps coming. Okay? That's what it looks like now. It's all done. Life cycle costs. This is an important one for the public that they don't really understand. Most of us understand capital cost. That's your first cost. That's the cost that you put in to build something, right? To build this chair, whatever it is, right? There's a first cost in order to build that. Life cycle cost takes into what's the total cost of ownership of that chair, of whatever it is, over its whole lifetime. Okay, this is the model that Tesla uses to sell their cars, right? It's total cost of ownership, right? And they factor in that you get to use the carpool lane, that you save money on gas, right? That you can charge it at somebody else's charging station, right? So you don't even have to pay for that, right? They add in all these things. It's total cost of ownership. That's life cycle cost. Okay, so when we're doing these projects, life cycle cost is an important component because, one, yes, you have to pay for what's there, but then you've got to take care of it over the whole life. Okay? And I had an interesting conversation before this, and one of your students, my new friend Brenda, right, and I were talking, and she was saying, well, the science is proven for doing recycled water, right? And I said, I don't disagree with you. The science is proven. We know how to do it. We know how to make it safe, right? That is not the problem. The question really comes in is, after you build it and you know it's working right, 10 years later, how do you know it's working right? Did you take care of it the whole time? Did you change the oil, right? Did you change the tires on your car, right? All these other things to make sure that it's still working right 10 years from then, from when you started, okay? And that's where life cycle costs, that's where O&M, operations and maintenance comes in, and it's really important. You can't just pay for something one time and expect that 10 years later it's going to work great when you need it to work. That's not how things happen, okay? It'd be sort of like if you took your car and you said, I don't really feel like buying new tires because I don't have the money, or I'd rather spend money on something else. And then you drive around on your bald tires until it starts raining. And then you crash your car into a tree, and you're like, dang it, I wish I would have had new tires, right? But at that point, it's a little late to start worrying about getting new tires because you just wrecked your car, okay? These kinds of facilities are the same. you have to take care of them over time or else they won't work when you need them to. Okay, so life cycle costs. Use this analogy of the iceberg because the capital cost is just the tip of the iceberg. There's lots of other costs that go into it and need to be considered as you're looking at how to implement a solution to a problem. So one of the things that we had at this plant was they had centrifuges that spun really fast, and they dried the solids, and they put them in a truck, and then they would haul those off, in this case, to Arizona. And it cost $56 a ton to haul our old waste product out of the state to somewhere where they use it for composting, and that $56 a ton. And this, tons and tons of it are produced every single day. They were paying $700,000 to $800,000 a year just to haul that sludge out. It's just a waste product. They're hauling it off. So one of the things that we recommended to them was, let's dry it. So regular solids like this, they come in, if you think about just easy percentages, okay? 20% of it, roughly, is the solids, right? It's the stuff that we put in. 80% of it is water. So they're paying $800,000 a year to haul, basically, water to Arizona. That seems like a bad idea, right? Like, why would you do that? Okay? Well, so we talked to them, we convinced them that we should put in these facilities to further dry the solids, and so we're flipping the economics, okay? What we want to really haul is the waste product out, not the water. We'd like the water back so we could use it for recycled water and other things, okay? So we implement this drying technology, these greenhouses that automate the drying process. Basically what we do is we flip the economics, and we get about 80% dry solids and 20% water, right? And we reduce the cost down to about $250,000 a year, right? So they're saving $400,000 or $500,000 a year in just hauling costs, hauling off what they really need to haul off, and we're getting back all the extra water that was tied up in those solids. Now we can treat that and produce more recycled water, okay? So just a more holistic, more sustainable approach to part of the treatment process, okay? Get rid of what you need to get rid of, but don't send away the good stuff that you want, okay? But it costs a little bit more to do it. But there's positive paybacks based on the savings, okay? We said one of the things that we want to do is reduce operating costs at the plant. We worked with Southern California Edison, and through all the improvements that were done, cut down their energy consumption by millions of kW over a 20-year period. And Edison was like, awesome, great. Now we can take, just like recycled water, right? You swap it and you sell that water to somebody else when you can implement recycled water. Edison's saying, okay, great. We're taking energy off the grid. We can use that to go power up something else, and we don't have to build anything else. And so they gave the Wastewater Authority a $500,000 check. Not a bill credit, not a pat on the back, a check. This was like a giant Publishers Clearinghouse check that they brought to the meeting. Handed them a check for $500,000, okay? This makes people like you guys super happy, right? Policymakers, when they get a check and they get to stand up and hold the check and show their constituents everything, look, we got a $500,000, makes them super happy, right? They saved probably $20 million of what they would have bought for Edison, and they got back $500,000, right? So you take a step back and you're like, oh, okay, all right, that's great. But when the big check shows up, everybody's super happy, right? They're just like, yes, we got a check, right? So that was good. We checked off one of the objectives of the project, lower the capital or the operating costs. So this is what it looks like now, okay? It's all done, it's operational, new facilities, right, all through here, everything's online. We still have neighbors over here that are not super happy. We've done a lot of things to make them feel better about it, implemented all these odor control facilities throughout the plant, try to make it better. It's still a wastewater plant. At the end of the day, it is what it is, right? I mean, we all have fans in our bathrooms for a reason, right? I mean, it is what it is, right? But we've done a lot to try to make it better. The owners have spent a lot of money, done a lot of outreach to try to make it better. And like I said, the plant is now getting ready to start delivering recycled water, which was one of the promises of the project out into, this is Eastvale, right? Out into Eastvale. They're just about ready to start being able to implement recycled water infrastructure to be able to send that out into Eastvale, take potable water off the grid, right? And use it, exchange it for recycled water, be able to water parks, frontages, you know, all those things, and be able to take that other water and not have to spend money to produce new clean water. So it's been a big success. We hit our budget, which also makes the policymakers really happy. It finished right at just over $72.5 million, like 72.7, right? So we were right on where we needed to be. And it's operating, and everybody's pretty happy about it, minus the last lingering concerns about odors. So this is one of the last things is when you go into something like this, you got to kind of think like, what scares me about this? And what are we going to do to try to overcome those fears, those concerns about what it is, okay? And there's lots, for everybody it's different. I just threw a few of them up there. Some of these are ones that would scare me. Some of them might be ones that can scare you, right? You got a contractor, or how are we going to commission it, get it started, construction documents, equipment, neighbors, right? We got problems there. Can we get it online on time? Budget, right? All of those things. Everybody has their own set of things that make you worried about something, a project like this. Understand what those are and talk to the people who are responsible for implementing it. And what are we going to do about this, my concern, right? My constituents don't like this because of this reason. What are we going to do to satisfy their concerns and make them feel okay about it? Because ultimately, you got to make sure that the public is reasonably happy about this so we can keep moving forward doing things. So everybody has their own set of these. Understand what yours are, right? And talk to the people who can help you either explain it to the public, explain it to you so that way you can try to satisfy yourself that we've got this covered, okay? With that, I think I'm done. But we have time for questions.
Time for a couple of questions. Anyone?
Yes.
I have a few. Pick which you want to answer.
All right.
Speak a little bit louder.
The change of use, the permission to remove discharge to the river. Riverside is also laying pipe, hoping to reclaim water.
Yeah.
Will that change of use permission affect Riverside's ability to get permission? Second is, what Corona had a plan and they're closing it down. Is that what happened? And third is, do you have to worry about fire suppression when you get biosolids that dry?
Okay, very good questions. Corona has three plants. They figured that one of them was a little bit too expensive to operate, that they could recognize some savings by joining here and decommissioning a plant that needed to be upgraded and have some enhancement done to it. So they just, in their overall planning, this is a better outcome for them. Yes, there is issues if you get solids too dry, right? We can't get above kind of, it's like 95-ish, right, %. So we have to pay attention to that, make sure we don't get solids too dry. There's dust issues. So there's a pretty robust ventilation system in there to try to make sure that that doesn't happen. Change of use petition. Currently, they don't seem to be negatively impacting each other, but there is a concern that that could happen, right? There's just, how much water can you take out of the Santa Ana River before somebody finally says, well, wait a minute, right? But like I tell my kids, don't go swimming in the Santa Ana River because most of the water, especially in the summer, is somebody's treatment plant effluent. So without all of that, from San Bernardino all the way down, there's probably not much water left in the Santa Ana River during the summer because there's not that much snow up in the mountains. So don't go swimming in the Santa Ana River, just my word of advice. But currently, they don't seem to be negatively impacting each other. But there is a concern that at some point they could. Yeah, and Riverside's looking to pull out water. Corona did theirs a few years ago, and San Bernardino's looking at potentially maybe doing some. So yeah, there is problems there, potentially. Yes.
Brian University of Ranch Customer Water District.
Hello, Angel.
We actually have our wastewater facility down there. Sure, look at it sometime. But my question to you is, what is your yearly operating cost on this facility?
I don't know what it is right off the top of my head.
Who oversees it?
Western.
Okay.
Western operates it on behalf of the JPA. They operate it. I don't know what it is. I know relative to pre and post improvements that were made, they're saving somewhere near. Last I saw, they were trending about $800,000 less this coming year than they were the previous year before these improvements went online. We got rid of the UV system, which is a huge energy consumer. The way the aeration is being done is a significant improvement from an energy standpoint. So yeah, they're trending significantly lower. From a total connected energy consumption, what they were doing at about 6 million gallons a day, however much energy they were using, they're not going to get back to that level until they get to about 11 or 12 million gallons a day, until they get back to that energy consumption level. So nothing else has dramatically changed. The staff is still the same. All those other things are kind of the same, but energy consumption is the biggest one that's dropped significantly. So, any other question? Yeah.
Does this facility have a finite expected life of when it might?
Yeah, I mean, facilities like this, they usually go through upgrades, expansions in the 15 to 20 year range. So a lot of the equipment, pumps and things maybe might last pretty solid for 15 years, and then you got to look at replacing things. The concrete in those structures will usually last, I mean, those can last 60, 70 plus years. That stuff is really long lasting. But the mechanical equipment, usually, 10 to 15, 20, somewhere in there, you've got to start replacing it. And so you've got to squirrel away money to be able to do that, right? And save money over time so that you can replace things when they need to be replaced. Yes?
I have one question
Yes.
too. You mentioned that there are 5 owners or 5 partners. How was the process of reaching an agreement on probably many parameters, like prices, level of treatment? How was that done? I mean, it was a negotiation.
There was. They get along pretty good, so the negotiations weren't really contentious, but there were a lot of things to settle on because they all had, this is maybe getting a little bit in the weeds, but they all had ownership of a portion of the existing plant that has 8 million gallons a day. So one of them might have owned 2, 4, whatever it was. So some of those things we replaced completely, like the filters. We took them completely out and we completely replaced them. So then it was figuring out what everybody's proportionate share of that was. And so there was some back and forth, and what they ultimately ended up on was that it's pretty complicated to figure that out on an exact basis. So we got them close, and then they all sat down and they said, that seems reasonable. Okay. And then they sort of just struck a deal that when everybody felt like they were getting what they want and they were getting a fair deal, they just memorialized that and said, that's our plan. And they didn't get into a fight about all the nitty-gritty details, which you could have, and would have been really hard to quantify because some of those things they're based on 5 assumptions that no one could prove. And so how do you then come up with something that's concrete based on that? So there's some negotiation once we got to a final point, and then everybody just said, it's a good deal for us. Okay, let's move forward. Yeah.
Okay. Thank you very much for the presentation.
Thank you for having me.